right, we're going to game with what I call maps, and maps are simply key value pairs, or a way to resolve a particular key to a value. So a key would be like an attribute, and the value is I guess you could say, for lack of a better term, the value for that attribute. So the goal of studying these key value maps is to improve our game. And the first thing we can talk about really quickly is the usage of triple quotes. And you can easily go to many websites out there for free and grab some, for example, ASCII art. ASCII art is the drawings you might see in a command line interface that create some sort of a cool picture or a cool font. You can just grab those from any website and copy and paste, but for the purposes of time, we're just going to skip that for now, and I'll leave you to research it. But really, the biggest improvement is going to be the usage of dictionaries, and that's essentially what Python calls a key value map. They call them dictionaries. Other languages call them hash maps and whatnot, but Python calls them a dictionary because it's easy to see why it would call that or refer to that data structure as a dictionary, because a dictionary, you look up a word, let's say aardvark, and it then shows the definition of it. It's the same thing with the key value maps of Python and the hash maps of other languages. So let's move on to the next slide. Why dictionaries? So to review, we recall a list is a group or collection of sequentially defined items. And when I say sequential, that is only made possible because when you create a list in Python, it resolves each item to a particular offset. So for example, in this list of bowling scores, we have 187, 100, 101, and 300. So that could be one person's bowling score. Maybe he started off okay, then he got tired and he faltered, and then the next frame he didn't do much better, but in the final frame he figured it out and bowled a perfect game. So how that resolves to the sequence is that the 187 resolves to the 0 offset, or the first offset, however way you want to look at it. Of course, we know that computers really begin with 0, so that's the 0 point. The next score is resolved to the number 1, which is 1 right after 0, and the next score resolves to 2, and so on and so forth. Now, the good thing about lists, or arrays, as other languages call them, specifically Java might call this data structure an array list. The good thing about how they utilize this offset in memory, because at the very least it does support order. So it provides the idea, or it facilitates the idea of sequencing. So you have 0, now the one after 0 is going to be 1, 1 after 1 is going to be 2, and 1 after 2 is going to be 3. So it supports and facilitates the idea of saying, okay, bowling scores, the second index right here would be in fact a 101. Now, I just explained to you what we already knew about lists, and furthermore, I just explained to you why lists are good. But again, it begs the question, what is the advantage of using maps or dictionaries in any gaming environment? Well, or in any environment at all. Well, for example, bowling scores in this particular case gives us, dictionaries keeping track of bowling scores gives us more information than a mere list, because look, we can see who exactly got which bowling scores. So we have Kip wind up getting the 287, J-Rock, who's a friend of mine, he got 100, Alan, who's a mutual friend of ours, got 101, and of course your Professor J, got 300. Now keep in mind, when I say bowling scores, I'm only referring to playing on the Wii, just so you know. This isn't real bowling scores. But anyways, while this list resolves an object or item to an offset, so in other words, while the list does resolve this particular object or item or value to an offset, now keep in mind, a list could be anything. It could be an object, it could be another list, it could be a tuple, it could be a dictionary, in of itself, or it just could be a human readable name. So that's what I mean by this. But it's saying that while a list resolves an item them to an offset or a sequence, a dictionary maps or resolves a key to a value, giving us more useful information. Now, it's great that we have these numbers here, 187, 100, 101, but it's really tough to put them in a context as to what exactly these numbers are, but yet we can kind of see what's going on here. Kip obviously bowled a 287, J-Rock bowled a 100, and whatnot. And the visualization of what a bowling score dictionary looks like is we have Kip here. He is mapping to the value of 287. J-Rock is mapping to the value of 100. Alan is mapping to 101. And Professor J is mapping to the value of 300. So in other words, there is a connection there. So the format is going to be the key itself, colon. Now the mapping occurs with that colon, and then we have the value. So we have key 1 and then maps to this value. Key 2 maps to this other value. And then of course what's very important is that we have the open and close curly braces. Now the keys, now there's a couple of things that are the bare requirements, the bare bone requirements of a dictionary. So as it says, the key itself has to be hashable. So by hashable, I'm not going to get into that right now, but I will tell you that the hashable data structures in Python are strings and tuples. So tuples, if you recall, is just anything with when you have an open and closed parenthesis. So a tuple is like a list, except a tuple is not changeable. It is immutable. Now, without going into the details that would stretch this video out even longer than it already is, just know that for now, just to keep things simple, we're going to represent the keys as strings. And of course, the values can really be anything. But in this case, of course, it makes sense that the bowling scores are mapped from a string to an integer, because that's how you keep track of bowling scores, is integers. Maybe if you were doing, instead of doing bowling scores, you were doing transactions, like that night that us wild and crazy guys went out to bowl, maybe we can map the orders from the concessions that we got. So Kip paid $8.20 for pizza and pop. J-Rock bought some candy, and his bill was $4.02, and then Alan, maybe he got whatever, and then Professor J, maybe I got hot dog and a pizza, and it cost me $5.24. So that would be a nice thing to keep track of. The other thing is that the key values must be separated by a comma. The different key value combinations or associations, really they're more like associations. So every time the string is associated with a value, if you have multiple ones, which in dictionary, of course, you're going to have multiple ones, they are going to be separated by a comma, as you can see. The other thing is that the keys themselves must be unique. So what that means here is that you cannot have two names that are K's. So for example, you can't have two Kips. So you can't have two Professor J's. You can't have two J-Rocks, because there's only one of each key. It's just the way it is. One of the aspects of something that is hashable is that they have to be unique. So in other words, and the other thing is you can have different values that are the same. So you can have two people that bowled a 100, but you cannot have two of the same people. All right, let's take a look at hash maps usage. How do we use dictionaries in real life? So here we can, with bowling scores, obviously we can keep track of bowling scores, but even a more elemental view of this is we'll say D1 equals, and then we'll do string A is mapped to the number 1 and the string B, and you notice here I'm using single quotes as opposed to double, just to show you it can be done, is mapped to 2. So if we go ahead and print D1, we will get A is to 1 and B is mapped to the number 2. And that is similar to, we have the bowling scores here. Now we can also use the dot keys right there, the keys method. So we'll say D1 dot keys, and it will actually list the keys keys of D1 as in A and B. So in other words, it's simply taking the keys portion and mapping and basically adding them and printing them out sequentially. And we can also do the same thing with values. So we could say print D1 dot value. See how we were able now to this time, we're able just to print the values all in one line as opposed to having two separate lines here with keys. And we can also say that the dict keys AB is mapped to a list. So we'll say D1 list is equal to D1 dot keys. So we'll say D1 list, and that is dict keys. Now we can also turn this into a list, like turn this right into a list. So we can say D1 list equals list keys like this, and then now we can say print D1 list is A and B. Do you see how we were able to do that? Same thing with this. We have bowling scores keys, bowling scores values, and then we can say for I in bowling scores dot values, and it will print the values all in a row. Similar to this, we could say for I in D1 dot values, and then we can say just print I, and it would just print them like this, 1, 2. Or we could say for I in D1 values, print I, and then end equals an empty space, and we could get a kind of like the values going across like that. All right, and same thing with here for I in bowling scores, it would list the values all in a row. It would say 20, 287, 100, 101, and 300. Now it says 100 in bowling scores values. That gives us true. So for example, we could say 2 in D1 dot values, and it would say true. And my apologies that that went off screen. Let me go ahead and drag this up here. Now on the other side, to get a false value, all we have to do is state something that's not in the D1 dictionary right here. So we'll say 3 in D1 values is actually false, similar to maybe something here if we would have said, for example, if we would have said 288 in bowling scores in dot values would be false. Okay, now we can say list dot deck dot keys. Okay, so imagine, if you will, if we actually had a dictionary for a deck of cards. All right, so I'm going to go ahead and exit out of here and then run the clear command so we can get back on top here and to go back into Python 3. And I'm just going to say deck is equal to the dictionary 2 of hearts. So that's one of our keys, and that's mapped to the number 2. And we can say 3 of hearts right here, and that is mapped to the number 3. And we can say, we can print out the deck to print out our entire dictionary. So the value of this is that we can say something like deck, similar to our other dictionary. And let me bring that up here. I just exited out here to save space. And let me go back here. D1 is equal to D. A is mapped to 1 and B is mapped to 2. So we can say D1A here is mapped to 1, D of B. D1 of B is mapped to 2. Similar to deck, and we have 2 of hearts, that is mapped to 2, and we have 3 of hearts, and that of course is mapped to 3, mapped to the number 3. Now we can have somebody add an unlimited amount of elements to D1. So for example, we'll say while true, and actually let me go ahead and do this in a Python file. So I'll be right back. All right, let's take a look at something here. I'm going to go ahead and go back to my trusty D1 dictionary right here. I did want to mention that we can say D1 of A is going to be 1. That's the format of how we can get the value from a particular key. So again, that maps out to 2, and I did create something here, just the kind of like a treasure chest game. And here it is right here. What this does is this is a continuous while loop. And wouldn't you know, I make a mistake right there. This is a continuous while loop that's going to add a key for as long as you tell it to until you press and type 0, and then it will print out the treasure chest or this TC dictionary right here. So while true, object equals input, enter the new object into the treasure chest and press 0 when done. Now, how I facilitate the condition of pressing 0 when done, that I have the while true, and as long as the object does not equal 0, then it will continue to ask, enter the object's worth, and then this is the key thing right here. TC of that object is equal to whatever your object is worth, as whatever the user puts in, and then we'll say else break, and then thank you for filling up the chest. Here it is. That is the delimiting condition. So it is the condition that occurs, or that is the statement that occurs once you get out of the while loop. So let's go ahead and let's run it. Python 3 treasure chest, and enter new object into the treasure chest. We'll say arrows, enter their worth here, 30. Let's say enter a new object. Let's say gold, and that is worth 100. And let's say armor, and that is worth 20. And I said arrows before. How about a shield? I'm thinking like Skyrim world here, and that's worth another 20. And I'm going to type 0 when done, and of course it lists everything in the dictionary here. So it would be interesting if we could now then print what the value of the treasure chest is. All right, so I have to admit something, that I wanted to make sure, I wanted to see what kind of values, or what kind of methods were available to me. So I went back to the Python 3 idle, and I went back to the D1 equals A of 1, and B is mapped to 2, and I said D1 values, I created a new variable here, equals D1 dot values. So I used the values method to essentially list out just the values of 1 and 2. But this time I then said, okay, if I can create a list, I could see if this D1 values list has a method that I can just add them really quickly and easily. And I see all the methods right here, and there's nothing here that says sum. I thought maybe there was like a dot sum method. It would be nice, but there is not. So then I was like, all right, I'm going to go ahead and say that I'm going to create a list of D1 values, and here is the list. Here's the command to create D1 values as a list. So list D1 values right here, and then I forgot to declare D1 values total, because it says D1 values total is not defined. But then I said D1 values total equals 0. So I then used a for loop to my advantage. I said for I, or iteration, in D1 values, which is the list that was created in this with this command right here. I then just simply said for I in D1 values, and every time it's iterated, it's going to add to D1 values total, which starts at 0, but then it increments by I, and then I wind up with D1 values total is equal to 3. So this is an example where you would use the idle or your interactive mode to your advantage, because I wasn't sure off the top of my head if a list didn't have a sum method. You think it would, but I just made up my own sum way of getting the sum of these dictionary values just by using a for loop and iterating it through the list that is created and just adding it to a reference variable. So I'm going to exit, and let me run clear, and let me go ahead and run Vim and get back into the values right here. So here I have a list of values, and I'm going to run into a problem right here, because the input that I gave here is going to be as a string because that's what the default value of input. So I'm going to do myself a favor right here, and I'm just going to say this is an int value so I don't run into any problems with summing this list right here. So right now, this list is a bunch of integers, which is what we want, and I'll say for I in TC values. It's too bad this Vim doesn't have autocomplete like other things do, like other IDEs do, but anyways, and even before I do that, I have to create a reference variable, so I'll say TC value total equals 0. So I just, I guess you could say I just abbreviated TC value total. So I'll say for I in TC values, and I'll just say TC VT, value total plus equals I. And then when that's done, when the for loop has finished, I'll say print, and I'll use the formatted version. I'll say total value sum of treasure chest is colon, and I'll say TC underscore V underscore T, and close that, press period, and close out the parentheses, and close out the I said close out the parentheses, I mean close out the quote, and then close out the parentheses. So hopefully this will work, and let's run this treasure chest again, and we'll say gold, and that's worth 100, and we'll say arrows, and that's worth 20, and then I'll say 0 to end this. All right, so the total value sum of treasure chest is 120. Go back to this very quickly. D1 is back to being A is associated with the value of 1 and B is associated with the value of 2. And we can say D1 equals list D1 values. And we can import. Now, here's the thing. To get some unpredictability, we can import a random, I guess you could say, value from the D1 values list that we created right here. So we could say D1 choice is equal to the random dot choice, because we did import random right here, and we're using the dot choice method, and it's going to select randomly from the list of D1 values. So here we printed the D1 choice, and it prints out 2, and we could continue to print out D1 choice, and it would probably kind of vacillate between the values of 1 and 2, because it's taking the list of the randomized choice from the list of values right here. We could do the same thing with keys, and that is the key right there. And so D1 equals random dot choice keys is equal to A. But as a user, we only care pretty much what the value is. Like if we were doing a deck of cards, for example, 2 of hearts is going to be the same value as 2 of clubs, unless, for example, hearts are wild or clubs are wild. But if you were playing a game of war, 2 of clubs and 2 of hearts would actually be a draw. So here we say D1 random choice keys, and then of course D1, and I'm just saying D1 underscore equals random choice keys. D1 underscore in this case is A. If we did that over and over and over, we would wind up sometimes it's giving us A, and sometimes it would give us B. But what we're worried about is the value of A, which of course is going to be 1. And let's do this again. Let's say D1 equals random choice keys again. And then we want to print D1, D underscore. This time it is B. So this time this command D1 of D1 underscore would give us 2. The number 2, because it corresponds to the associated value of B right here. I hope everyone understands this, and we can extend this to another game. All right, let's take a look at this game that we created. Here's import random. Here we have our deck of cards. Now we can take this deck of cards as a dictionary out as far as we want to. We can even have a 52 card deck, or we can only have all of one, maybe a couple of suits. So 2 of hearts is mapped to 2, 3 of hearts is mapped to 3, and then 4 of hearts is mapped to 4, and so on and so forth. And we can do spades as well, or clubs, or diamonds, or whatever you want. You can have all of them. So playing deck is equal to the list of the keys, and this way we can randomly choose from the keys. So for example, maybe it chose the 2 of hearts. So here, this says the dealer shows the dealer card, which is the choice of the randomized choice out of 2 of hearts or 3 of hearts. And then it'll translate that into a score by saying the integer value of the deck, and the index is the dealer card, and we have the value right here. Let's go ahead and let's see this in action. It would be nice if you guys could see this. Let me bring this up here. All right, so hopefully you can see it right here. I'm going to type clear so we can clear out the screen. So I'm going to say python.3 map game, enter. So the dealer shows the 2 of hearts, so the dealer's value is 2. So my challenge to you is to say, okay, if we can establish what the dealer card is using this methodology or this framework, what would the user, how could the user show what he picked? So in other words, can you take this deck and modify it so you can increase the amount of suits or the amount of cards, and then have not only the dealer card but the user card? And how would you compare them? So for example, could you say if the dealer card is greater than the customer draw, then the dealer wins, and vice versa, then the customer wins. And you can also integrate what we talked about in terms of a bank. So I leave the challenge up to you.